This is part 5 in the continuing screencast series Refactoring to a Solid Foundation, where we explore the application of the solid object-oriented design principles to an existing software system in order to understand how the principles apply to improving the design of our software solution. In our prior installments, we took a look at the single responsibility principle, the open-close principle, the Liskov substitution principle, and the interface segregation principle. This leads us in this installment to the D of SOLID, the dependency inversion principle. The dependency inversion principle, simply stated, says, high-level modules should not depend upon low-level modules. Both should depend upon abstractions. It goes on to say, abstractions should not depend upon details, but details should depend upon abstractions. So this is a clever way of saying something that sounds more complicated than it actually is. The second part, let's tear apart first because it's the simplest and easiest to understand, which basically says that anytime we have a relationship between our classes, that relationship should be stated in terms of abstractions rather than concrete implementations. In the .NET environment, typically our abstraction elements are abstract base classes, or for that matter even just base classes, and more commonly interfaces. So these are typically at the class level, the abstractions that the framework gives us to deal with. And so in essence this is a statement that the relationship between classes should be in terms of interfaces and abstract base classes, rather than in terms of concrete implementation classes. Up above, the first statement here basically says that high-level modules should not depend upon low-level modules. In essence what this means is that when we have a high-level module, it should not be responsible for constructing its own dependencies. Rather, it should have its dependencies handed to it, typically at the time of construction, in order that something outside that high-level module is responsible for handing off the details of the low-level modules that the high-level module depends upon. When we take a look at our refactoring exercise in this installment, hopefully some of these principles will become a little bit more clear in terms of their application. So let's come over to our software solution and start applying this principle to improving our design. Alright, we're here in Visual Studio 2008. We have our solution open from our last screencast installment. We're going to pick up where we left off and introduce the dependency inversion principle in order to further improve the design of our class model right now. So the first thing we're going to do is actually get started with the second part of the dependency inversion principle, which basically says that we need to set relationships between our classes in terms of abstractions rather than concrete types. So within our solution right now, we actually have a couple of different places where we have a violation of this. Let's start at the top of our project and work downward. So we're going to begin with the program and the main method right here. And what we can see is here's a relationship between the main method in our program class and a report instance inside that class. And so one of the first things we're going to realize is that here is a relationship between our program class and our report class that is in terms of a concrete instance rather than an abstract type. So what we're going to do is we're going to come over to the definition of our report class, and we're actually going to introduce an interface for it. So let's do that and extract an interface. We'll call it iReport, and that's perfectly fine. We can leave it exactly as it is. So now what we want to do is come back to our program, and now that we have a report interface, we can actually define our main method in terms of an iReport instance rather than a concrete report type. Once we do that, since we lack any unit tests in our project, we'll have to go on ahead and hit F5 to run the thing, see if it actually does run. And in fact it does. It still does what it used to do. So it does get data, it does formatting for 11 by 17, and it does printing the report to a dot matrix printer. So again, since we don't have any unit tests, our only way to verify this is really still working as we do our refactoring is to run the application and observe the output. So we've taken care of that. Our next step is to dig into our tabloid report class. Let's look at its definition. So our tabloid report class is in fact representing a relationship between our tabloid report and our report printer instance. So our report printer instance represents another relationship between a pair of classes. These dependencies are in terms of concrete types rather than interfaces. So let's see if we can introduce a little looser coupling here by looking at the report printer definition and extracting an interface for that as well. So let's jump over to the definition for report printer and let's extract an interface for it. We'll accept the default of iReport Printer so that Report Printer now implements the iReport Printer interface. Once we do that, it becomes possible to come back over here to our tabloid report and change this so that this dependency is also in terms of an interface rather than a concrete type. So now what we want to do, again, is run the application. So let's hit F5, make sure it still builds and runs. And in fact, it does. No behavior has changed. So the essential tenet of refactoring that says we can change the function, or rather change the structure of our code without changing the behavior of the application, is still being respected. So now what we have is we have our iReport printer, and that's all taken care of. Our next step is to deal with the report formatter situation. So if we look, what we have here is inside the tabloid report printer, let's bounce over to its definition, what we see is that inside tabloid report printer we have two more concrete types. We have a report data access and we have a report formatter type. What we'd like to do is we'd like to do these also in terms of interfaces. Well, it turns out we already have a report data access interface because we did it in the prior screencast where we looked at abstracting out and doing a little bit of interface segregation on our previously very fat iData access interface over here. What we did was we extracted out of that an iReport data access interface, so that interface already exists. We can simply change the type here in the tabloid report printer to be an iReport data access declaration rather than the concrete report data access. Let's go on ahead and hit F5, run the application, make sure it still works. In fact, it does. Now, let's deal with report formatter. So, in order to solve this problem, what we need is a report formatter interface. Let's come over to the report formatter declaration, and let's extract an interface for that. We'll call it iReport formatter. That's just fine. Let's come back to tabloid report formatter, and now that we have that interface, we can actually change this type to also be an interface. Now let's go on ahead and hit F5, run the app one more time. Still behaving just fine. So what we've done is we now have relationships between our classes in terms of interfaces rather than in terms of concrete types. So we've got the second half of the dependency inversion principle all taken care of. Our next step is to move on and implement the first part of this, which says that complex types should not depend directly on lower level types. So let's take a look at that next. Our next refactoring is to use a technique called constructor injection in order to inject the dependencies for our higher order classes with their lower level dependencies. So we're going to start by taking a look at the main method in our program class. It basically at this point simply news up a tabloid report and calls print on that object. Let's investigate the tabloid report in order to see what its dependencies are. So tabloid report has a dependency on the tabloid report printer. What we'd like to do is, rather than having the tabloid report class responsible for newing up its own tabloid report printer, what we'd like to do is we would like to actually have the tabloid report class get past the appropriate tabloid report printer when it needs it, or more importantly, the appropriate iReport printer instance. So let's look at how we can do this. The first step is we're going to take the existing report printer variable here and we're going to refactor it into a field in our class like so. So now we have a field in our class called report printer. We don't need to assign its value there because what we're going to do, rather than set it inside the print method, what we're going to do is we're going to do a constructor here that's going to take an iReport printer argument. When we do that, we're going to stub that guy out, and now we have a tabloid report constructor that takes an iReport printer instance, and in the constructor all we're doing is simply assigning the passed-in report printer to the report printer field. So when that happens, what we'll realize is that now it's possible for whoever calls the constructor on tabloid report to be in charge of which report printer it's actually passed. So this code becomes much simpler. In fact, it becomes even simpler if we get rid of some of these things that are commented out. So let's do that right away. So now what we've got is we've got our constructor that takes the report printer instance, and we have our print method that simply calls the print method on the member field of type iReport printer. So if we compile this, what we'll see is we have an error. So the error here is that tabloid report doesn't contain a constructor that takes 0 arguments, and that means that whatever is responsible right now for calling the tabloid report class needs to actually pass in its dependencies. So let's go there. And sure enough, it's right here in the main method in our program class. So tabloid report now takes an argument of some particular type. So let's look at what that type is. So it is an iReport printer instance. Well, what we can do is we can simply new up the tabloid report printer that needs to be passed into it, like so, and send it in. Now, if we compile, it should build, and if we hit F5 to run it, then we should get exactly the same behavior. Again, getting data, formatting for 11 by 17, and printing to the dot matrix printer. The exact same behavior as before. The difference here is that tabloid report is now being told, hey, I want you to use this iReport printer instance, rather than the one that you were previously constructing for yourself. So now let's look at tabloid report printer's definition in order to look at its dependencies. So tabloid report printer has a couple of dependencies of its own. It's got an iReport data access member, and it's got an iReport formatter member. Let's do exactly the same thing as we did before and introduce some fields in order to handle this. So let's refactor to introduce a field here for our data access member. We'll put it up there. It'll be called data access. That's fine. Let's come back down here and let's introduce a field for our report formatter. Again, we'll call it report formatter, so that's fine. We'll accept the default. We don't need this code right here. We can comment that out, because rather than assigning these field values in the print method, we're going to, once again, use constructor injection in order to get these dependencies into our class. So let's stub out a constructor that takes the following arguments, and, we'll accept both of those. And now we have a constructor for our tabloid report printer that takes an iReport formatter instance and an iReport data access instance. And in the body of the constructor, of course, all it's doing is simply assigning these values that are passed into the fields in the class. So we should, if we hit F6, have the compiler immediately tell us where we're calling tabloid report printer and not passing in its required dependencies. So let's go to where that is. Whoa, lo and behold, it's taken us right back to our main method in our program, pretty much just like we hoped, because we want to be able to control all of the dependencies for the downstream lower level classes directly from the upper level of our program. We want to tell it which formatter to use, we want to tell it which printer to use, just as we're telling it which printer to use, we want to tell it which formatter to use and which data access to use, and so on. And so what we see here is that if we look at the tooltip here, we need to pass in a report formatter. So let's do that. Let's go new tabloid report formatter. And then we need to pass in a data access. Let's do new report data access and pass that in. So now we're passing in all of these dependencies in this one big long line right here, where we're simply newing up an instance of iReport. And if we hit F6, hopefully it'll all build. That's good. And if we hit F5, we should get exactly the same behavior. Again, getting data, formatting the report for 11 by 17, printing the report to the dot matrix printer. So our refactorings, just as the definition of refactoring calls for, have changed the structure of the underlying code in our software without impacting the software's behavior in any way. So we've improved the flexibility of this, because now none of these downstream classes need to be responsible for constructing any one of their particular reports. In fact, we can see this because if we change the behavior of this at all, we can actually control all of these dependencies from right up here. So if instead of sending in a tabloid report printer, we wanted to send in the letter report printer, we could simply do so by changing this dependency right here when we pass it to the tabloid report class. And everything would change in the software downstream because it would be using the letter report printer rather than the ledger or tabloid report printer. So the advantage of this is that we get to control all of these dependencies from right here in our high-level code. In a production software, you would probably manage these dependencies using an inversion of control container, which allows you to register each one of these dependencies with the container and have the container responsible for interrogating the constructor signatures and passing in the dependencies. If you're interested in understanding how to manage some of these complicated dependencies using inversion of control containers, there are a number of other dimecast.net screencasts available for download that provide some very good introductory snippets on how to get started with particular different inversion of control containers, including Structure Map, Castle Windsor, AutoFac, and others, and so on. So worth taking a look at. But that takes us to the end of this one because we've managed to successfully refactor our code to use the dependency inversion principle. And at this point, that also takes us to the end of our screencast series on refactoring to a solid foundation, where we have managed now to successfully take our code and modify our class diagram and our code so that we get the benefit of all of this flexibility. We have granular classes. We have the flexibility of injecting dependencies where we need to. Each class has just one thing to do. So that's our separation or our single responsibility principle, or separation of concerns, and the other principles that we looked at in introducing the SOLID concepts here. So I hope everyone has found value in these screencasts, and any feedback and so on is appreciated. Thank you very much.